Algebra 2B students, this is a tutorial video for the workbook of 2.3. We're going to be looking at transformation rules of exponential functions. So we're taking some of these transformations that you've already explored in Algebra 2A. I think you looked at them again earlier through this lesson, but we're applying them specifically to an exponential function. So just looking at these two graphs, f and g of x, we have two exponential functions. I can tell that they're exponential because of just the shape of both graphs. They're that gentle curve. Both are going up in a steeper motion, so I would classify both of these as an exponential growth. But then also I can clearly see that both of these graphs have an asymptote. So for the blue graph, I can tell that the blue graph was approaching on the left-hand side, the asymptote at y equaling 0. And then the pinky red graph has a different asymptote. It's flattening out over here at what looks like to be -5. So those asymptotes are going to be really helpful for us when identifying transformations. Because now I can tell that to change from 0 to a -5, this graph has probably been translated specifically down 5 units. So just use that as a tip. Now, before we look into the examples, I also want to take a minute to just remind you about the types of transformations that we can have. I can have a parameter of a that is multiplying out inside of the function. I can have the parameter of b that is inside of the function. I can have the parameter of h also inside of the function, and then k. So the a's and b values, these are going to be dilations. And then the h and the k's, those are going to be transformations. I apologize for my handwriting. It's not great to begin with, and then I write on a tablet and it gets bad real quick. Okay, so let's look at first example. So here I have the what they're calling the pre-image. So this is the original graph, and I can see that this is an exponential function because of the shape and the curve, and I can see the asymptote down here. And we want to essentially compare that with the red graph to be able to come up with what's happening for the transformation. So it was very kind of them to give a coordinate point of 2, 9, and then 8, 9. I can very clearly start to compare those two coordinates. I can see that the y coordinates are the same. So there hasn't been any shifting up and down. There isn't going to be any stretching in these because the y values are going to be the same. So that means that the parameter of a, there was no stretching up and down. So it's not taller, it's not shorter. My y values are the exact same. So there is no a parameter. So no vertical dilation. This was not shifted. So the entire graph of g was not picked up and moved up because my y are the same. So that is the k value. There is no k value. So now I'm just thinking about, do I have a b? Was this made really fat or really skinny? So that would be a horizontal dilation. Or was this just picked up and moved to the left and to the right, which would be my h? I can kind of start to compare. The asymptote is the exact same. So this wasn't compressed or stretched. It literally, to me, just looks like it was the blue graph of f was picked up and then moved to the right. So this moving things to the right, and I can tell how many units to the right by simply comparing the number of 2 to the number of 8. It's moved to the right 6 units. So then if we go ahead and read the explanation down below, it's a mathematical explanation of what that is. We've identified it's a horizontal translation, so this is the h value, and it is moved to the right 6 units. So that means that the h gets replaced by the number that it was translated by, which is 6. So moving down below, g of x is the exact same as f of x, but just f was moved to the right 6 units. So now if we compare the original function of f of x, so f of x is 3 to the power of x. So remember that was my original graph, but then my new input is x minus 6, so that's why it becomes an x minus 6 right here. So the I keep on wanting to say green. The red graph up above has this function g of x is equal to 3 to the power of x. So that's still the exact same shape of the graph. It's just now been shifted to the right 6 units. And so that h value of 6 within the original function of 3 to the power of x is what denotes it to be shifted to the right 6 units. Okay, so let's look at the next example. I think we get a different type of transformation. So again, comparing the original graph, so the blue graph with the red graph, I can still see it's kind of been moved over, but something strange is going on right here. It wasn't like just the blue graph got picked up and moved, because the shape of the red graph, see that curve is a little flattened out. So I'm not thinking there's an H. There wasn't any shifts up, so no K values. Same idea as last time, 9 and 9 are the same, so no shift, no stretching up and down, so no A value. But if we look down below and continue to read, there is a B value. That's what's creating this horizontal stretch. So the B value stretches things to the left and to the right. So it makes things look really wide. So this point got stretched this direction. And then if I wanted to look at the coordinate, this would be like -1, 1/3. That got stretched in this direction. So it's getting stretched from the middle out. So how far out to the middle? Well, I can see that 2 got stretched to be an 8. So how far was that stretch? If we scroll down, we can see that the stretch was a factor of 4. So now we know what the B value is. So we can replace the B value with 1/4. And then again, looking down below, I'm having a hard time scrolling. Looking down below, the original function was 3 to the power of x, but now we just need to show that there was a stretch by 1/4. Okay, last example here. Now we have a original graph that has its own transformation of +3. So this entire function has been shifted up from just the original 2 to the power of x. No big deal, but how does the blue graph compare to the red graph? Well, as you read down below, you can tell that it's going to be reflected over the x-axis. So that is going to denote that we have to have a negative A value. But then I can also tell that the y values are a lot bigger or further away from the x-axis. So this 5 somehow got stretched to be a -15. And then in my mind, I can really see it when I look at the asymptotes. So look at the asymptote of the blue graph. It's at the y equals +3. And then if I look down here, this is y equals -9. So the same stretch that is happening from my y value of 5 to be a y value of -15, that same exact rule needs to apply from my asymptote of y equaling 3 to y equaling -9. So if we just think about how are those being being stretched, we can see that the A value would be a -3. So then applying that -3 to the original function, which is 2x plus 3, we can see that we do get this new value or this new function with the A value and then with what eventually ends up being a K value. So I hope that helps explain 2.3. If you have any questions, please do reach out.